All right, let's start the 4.4 notes. And in this lesson, you will find the lengths of segments using either segment addition, midpoint, or congruent segments. I'm going to skip on down to example number 5, where we're given the points B and C lie on segment AD. You're given that segment AD is 32 units long and segment AC is 23 units long. And that segment BD is 27 units long. So we want to find the length of BC. All right, so we're going to start with a statement of segment addition. We can say that segment AD, or the length of segment AD, is equal to the length of AB plus BC plus CD. So thinking about how we approached a similar problem with yesterday's discussion, and we do not have a specific value or expression for AB or CD. So how can we incorporate segment addition or segment subtraction, right, to write an expression for AB and CD? So using the givens, right, we can write an expression for AB by taking the length of segment AC and subtracting segment BC. Write an expression for segment AB. We're taking all of AC, subtracting off BC, leaving us with AB. All right, doing the same thing to find an expression for CD. We're taking all of BD, subtracting off BC, leaving us with an expression for CD. Okay, so now that we have a plan, now we can start substituting in the values. All right, so since we don't have a value for BC, okay, that's what we're looking for, right? How long BC is, right? We're going to say that BC has a length of X. All right, so we got AD, which is 32. AC is 23. BC is X. BD, we know, is 27. And then BC has a length of X. So there's our equation, which we're going to solve for X, which again is finding the length of BC. Right, so on the right side, when we combine all like terms, I get 50 minus X. Solving for X, I get X is equal to 18. All right, so let's see what you can do with problem number 6. Again, you need to set up your plan using segment addition or segment subtraction to write an equation to help you solve for X. So the plan for using segment addition, AD is equal to AB plus BC plus CD. Again, because we do not have a specific value or expression for AB, we're going to have to use segment subtraction to come up with one. And so AB can be thought of as taking the bigger segment AC minus BC. Now that we have the plan, we can now do the substitution for the different values. AD is 25, AC is 17, BC is X, BC again is X, and then CD is X. Okay, again, carefully simplifying the right side, we get 17 plus X. Solving for X, X is equal to 8. All right, skipping over to number 9. We're given that C is a midpoint of AB. We want to find the value of X and the measure of CB. All right, so using the given that C is the midpoint of AB, then we know that segment AC is congruent to segment CB. And because those two segments are congruent, then we know that their measures are equal. So AC is equal to CB. So that means we have our equation of 5x minus 6 is equal to 2x. So solving for x, we get x equals 2. And then plug that in to figure out the value of CB. CB is 4. Okay, I want to go back to example number 8. And I want to see what you can do here to solve for x and find the length of ST using the given information. All right, so we want to make sure we're careful in interpreting information that's given. For problem number 8, we are given that T is in between S and U. Okay. That is very different than saying, when we say in number 9, that C is the midpoint of AB. The definition of midpoint is, again, a point that is that cuts exactly the segment into two congruent segments, right? Some would like to consider it like the middle, right? But the word between, we do not want to mistakenly associate with the word midpoint or middle. Right? The definition of between is just a point that is somewhere within the boundaries of two endpoints. Between does not necessarily mean middle or midpoint. Therefore, if you wrote a statement saying that UT is congruent to TS or UT is equal to TS, then you've made the mistake of thinking that the word between is the same thing as midpoint. Okay, so again, this is not true based off of the given information. We do not know if T is a midpoint. It is not given. What we do know from the given information is that the bigger segment SU is equal to TU plus ST. So with that statement of segment addition, we're able to write an equation. Solving for x, we get x is equal to 4, and thus the length of ST is 28. All right, skip down to example number 12. Just find the value of z and then the length of LM and MN. Again, make sure you are sending a statement of either segment addition or segment subtraction, right, as the basis for your equation. All right, so we start off with Ln, the bigger segment. Ln is equal to Lm plus Mn. So there's our statement of segment addition. Then we can substitute the expressions for those segment lengths. Then solving for z, we get z is equal to 8. Plugging that in for z, we find that Lm is equal to 5 and Mn is equal to 12. All right, so let's finish off here with example number 16. Segment AP is 6 more than twice as long as PK. If AK is equal to 72, how long is AP? All right, so again, set it up using segment addition. You're going to have to also write your own expressions for the different segment lengths. All right, so if we let PK have a length of x, and since AP is 6 more than twice as long as PK, so an expression to represent the length of AP is 2x plus 6. Again, before we write an equation to solve for x, let's write a statement using segment addition. AK is equal to AP plus PK. Now we substitute the values and the expressions for the different segment lengths. Solve that equation for x, and we get x is equal to 22. Plug that in for x, and we get AP is equal to 50. All right, so that's it for today. Move on to the 4.4 homework.